Hello, my name is Leonardo Solorzano and this is my first lab and we'll be experimenting with the properties of charge. If you follow me for this first example, I'll be demonstrating when I charge this PVC rod with a cloth to negatively charge it, and we're going to see how the charges interact with a narrow stream of water. So as you can see, I'm charging up my PVC rod. And we're going to take a look at what happens when I get this rod that's been negatively charged closer to the stream of water. You'll notice that the stream starts bending and it starts gravitating towards the PVC rod. Now, you might be asking, why is that? Well, when we have charges like the PVC rod and the water that has two different charges in there, when they're opposite charges, the negative, and we'll see some positive charges in here, they start attracting, and that is what causes the stream to bend towards the rod. All right, for this second demonstration, I will be charging this rod with cloth. I'll be creating a negative charge due to the materials, and I'll be getting it close to this empty can of Dr. Pepper. Now, when I do this, you'll notice that it's kind of like magic that the can is coming towards the rod. There's no physical touch to it, but the can wants to come close. Why is that? When I'm charging this negatively, and I bring it in close to this can, which already has properties of negative and positive charges to it, all of the electrons on this rod are making their way as close as possible as they can to this can. And because of the can having positive charge, it also wants to get close to the electrons. So therefore, there is a force of attraction that leads the can to want to get really close to this rod. Now, what happens if I start charging this glass rod? Two different materials. Now, when I charge it up, this won't be a negative charge, rather it'll be a positive one. So let's see what this would look like when I get it close to this empty soda can. Well, you'll notice that it has the same effect. This can wants to be really close friends with this glass rod. Now, why is that? If it's two different charges that are completely different, why is it having the same effect? Well, this can also has a negative charge that wants to be really close to the positively charged glass rod. So because of that, it has the same effect. All right. For this third demonstration, I'll be demonstrating how this negatively charged PVC rod will interact with this electroscope. So as I'm charging this up, I'll get it close to this electroscope, and you'll notice that when I bring it closer to the ball, even when I touch it, that the leaves at the bottom are opening up. Why is that? It's because when I negatively charge this through this conductor here, throughout this whole electroscope rod, it's charged with a negative charge, and because of like charges repel each other, these leaves down here that are carrying this negative charge are repelling. That's why they open up. Now let me try this with a positively charged glass rod. Now, as I'm charging it up, I'm going to bring it closer here to the head of the electroscope, and you'll notice the same thing. You can physically see the charge moving towards the leaves of the electroscope and seeing them repel against each other. And you can even hear the little discharge. Now, if I touch it, I'm grounding the electroscope because I am consuming most of the electrons or the charge itself, therefore the leaves are just going back to their normal position. And this is the phenomenon of the electroscope. Thank you. All right, so welcome back. This is our last demonstration that we'll be having here, and it's going to be regarding the electrophorus. So I have with me a piece of wool and a styrofoam block that will be acting as my base. Now, when I rub this wool on the styrofoam, I'm just beginning to charge it negatively with the properties of the materials exchanging. I'm charging it up, essentially. I'm gonna be doing this for about 10 to 20 seconds, and that seems about good. And I have my Electroforce right here, the contraption. You'll notice that I have a plastic cup up here, which allows me to hold it, a paper plate that's wrapped in aluminum, and at the very end here, I have a bulb with a wire that's touching the aluminum, and then one that's open, which will serve as my ground. So I'm gonna place this Electroforce right here, and right now what we can't see, but what is happening is that this aluminum plate is being charged up because of the charged base. So all of the electrons will be down here or up here at the top because they want to be as far away as this negative charge here. So I'm going to hold on to this metal surface, trying to ground my negative charge to this right here. So I'm going to take a little hold onto this wire, and if you didn't notice there's a little spark. Why was that? Is because all of the negative charge wanted to make its way onto me. For me, I was its ground, so we physically saw it go through the circuit of the bulb. So that's what you saw there, and that's what that. Now you might be wondering why I don't need to rub the wool against this base multiple times to keep it charged. Well, I can just place this plate on this base, and it'll be recharged every single time. And you'll notice that because I'll put my finger on the bulb and it'll keep on lighting. And I can repeat this step as long as this base is charged. I can keep on charging my aluminum covered plate through the power of induction. Now, let's see if this can also work via induction. So induction is the same. This plate is going to be charged by this base without touching. So this is all being charged right now. Again, I'm going to go ahead and grab it. And if you didn't see it there, it lit up again. You could hear it. You could hear that little spark. And you can, I felt it. I felt a little zap. Now, we saw it work a little bit here. Now let's lift this thing up and see if it works just as well above it. We saw a little tiny spark there. I didn't feel it as much, but you got to see it. The further away I bring it from the base, the less charged it will be, hence the less lit up. Let's see if we have it over here. Let me charge it up a little bit. Let's see if I bring it over here. No charge. Maybe it's too out of the way. Okay, still charged up. But what happens now that I grounded it, there should be, in theory, no negative charge. So this whole thing should be positive because all the electrons scurried and they made their way out and grounded. So when an object is positively charged, it can pull on certain neutral materials. I have a pile here of small styrofoam, and because of it being positively charged, I should be able to, I don't know if you saw there, but I'm pulling the styrofoam, and it's looking like it's a snowy day here in Roseville because the styrofoam is just falling onto this countertop. And that's because these little things are charged as well, or well, not necessarily charged, but it's neutral. It's not charged. It has positive and negative little atomic beams in there, and all of the positive, or the opposite, since this was positive, all the negative little components, the electrons, are going to be wanting to go towards it. And because these items are so light, they lift up and they get attracted to the positively charged Electroforce. And there you have it. I mean, we got to see a physical demonstration, and we got to visualize what it looks like when an object is positively charged by induction.